functions, we said we treat them as a black box. Whatever we get input, we are expecting some output. This is how we define a function, right? We define the return type, and we said in C++, the return type has to be fixed. If it's double, you have to return double. If it's a string, you have to return string. And unless there can be some conversions, right? Implicit conversions, you can return an integer as a double, no problem, because the integers can be converted into double. But when you use the result of the function call, you will use the return value, right? Which is the double value. And we will see how it is used. So this is a typical way we write a function, right? We write a function, return type, function name. Function name could be any name. Then the parameters. We can have as many parameters as we want. And each parameters, there should be a type, then a name. The name could be any name you define, right? It could be any variable name. And there's a body of your function, right? These are the work of your function call. Here is an example. How can we compute the future value? So future value is computing the balance after 10 years, right? Remember the function power, right? Something to the power of some number. So it is the interest rate to the power of 10. So it is the balance, assuming your initial account has $1,000, right? Then after 10 years, what will be your balance? So here is how we can do it. Let me see if I have the code. No, let me copy that. Wait. All right, this is the first part. Then the main function. All right, got std. All right, so that's the function. Let me make them close to each other. Hide it. So this is the function, right? So we said when we read code, we always read from the main function. If the main function doesn't call future value, it will not call it, right? Let me do this way. If we comment out this line, wait, balance not defined. Let me define balance in here. Right, so we said main is the entry for any program. So when we run it, it will always run the first line of main, then one by one, right? Run it one, ask me to see in. Let me put a 10. Wait, 10 is not a valid number. What's the point? Let me put a breakpoint in here. Let's see what it will see. We run it. It asks me to input a number, right? Then it will give the 10 to the rate. Then we run it line by line, run this line, then return, right? That's the end. So if we don't run this line, it will not jump to this function definition. Even if the function definition is in here, it will not run it. A function will only be run if it's called, right? If it's called by the main function in here, then it will be running. So let's put a breakpoint in here. Run it. Give it 10. Then it will go to this line. The rate, current rate is 10. And we are calling future value with 10. And then when we run it, it will jump to this line, right? We are getting into the future function and then start executing line by line unless we meet a return. And now we see the P is 10. The reason is when we call future value, right? We get a rate to this future value, and this argument will assign to this parameter. This rate, the value of rate will assign it to p, which is 10. Then we will do the computation, compute the b. If we compute the b would be 25, 93, right? Then we return this b. Then we return this b. We go back to this line. So we have already called the function future value and get the number 2,500 and some number. And for now, the balance still haven't get the number until we execute it, right? Then the balance will get the return value of your function call. So function call have a return value. The return value will be assigned to the balance. And now you can output your balance, right? Now you can output your balance and print it. Let me put a new line here. All right, that's the whole process of function calls. Let's look at how it works. First step in main function, our rate is, for example, 5. Balance is nothing. Then we start calling future value function. When we call it, we will put our argument and copy it to the future value function, right? We copy the 5 to it. Then next step, with the value 5, this function starts computing the b, right? And the b is computed. Then future value is done, and it says return b, return b. And in return b, when we go back to the main function, whoever is calling this function, then it will copy the return value to your balance, and your balance will get the number. So that's the whole process of a function call, right? Basically copying parameters, then copying the return values. So any questions on it? No? Question? No? All right. So as we can see, this function has a few problems. First one, it hard-code 1000, which is the initial balance, right? Then it means this function can only be used for initial balance whose account has 1000 yuan, right? You cannot for any number. So what we want is we need to define another variable called initial. Then in this way, it can be used for any account, right? But this one has another hard-coded number is 10. 10 is the number of years. So what we can do is, okay, how about we give another one called a year to it. So now this function can be used for any functions or any account. It has some initial, right? It requires you to compute the balance after some year. So in here, when you call this function, you can say 1010, right? You can call your function like this. It will copy 1000 to initial, rate to p, 10 to year. It will do one-to-one mapping. You have 3 parameters, right? You have 3 parameters. Then I will give you 3 numbers, matching them one by one, and they have to match exact type, right? Double into double, no problem, because we can invert. You cannot say 10, right? Then there will be some errors because you are matching the first one with the first one, which is a string to a double value. There will be some errors. C++ is strongly typed, right? They will check every type of matching. So in this one, you will be errors. All right. So what's the benefit of defining it in this way? Defining a function like this, what's the benefit? The benefit is you can always change your initial value as well as your year, right? Let's do something we have already done. Let's forget about how these functions are implemented. We just need to know it's a black box. The black box takes initial value, takes the rate, and it takes the year, returns the balance after a few years, right? So let's forget about how this one is implemented and start computing what we have learned. Let me see if balance is 1. We are asking after how many years balance will becomes double, right? So what we can have is while the balance is less than 2 times initial balance, BALANC. What we do is, how about we compute, let me put another one, initial balance equals to 1. What else? Year, right? Int year equal to 0. If it's less, plus year. After years, we will get some balance, right? Familiar with this part of code? Getting the initial balance, and we are checking if the final balance is less than 2 times the initial. We will jump out. While it's less than, we will continue the loop, right? If it's greater than or equal to, we will jump out. So in this way, by the way, it should be different. It should be a year here, right? No, let me see if it's year 1. Wait, this one should be in here. Otherwise, it will be rounded by 1 error. If it's the first one, years is 0. When it comes in, year becomes 1. Then we compute is the balance after 1 year. Right? Then we compute the balance after 1 year. Then we check is the balance after 1 year less than double the initial. If yes, we can increment the year. Then we call this function again, right? We get the balance after 2 years. Then we continue on and on. Let's run it. Give it a 10. Wait. Oh, I forgot to change the initial balance. This should be the initial balance. Now, if I run 10, right? If it says after 8 years, the balance is some number that's greater than the double, right? So in this way, a while loop, or we can use a for loop, right? Sometimes we just need to practice. No, I don't need to define a new one. Year equal to 0. And if balance is less than this number, plus year, what we do is a compute the new balance, right? This for loop can also work. Familiar with while loop, for loop, any loop? Let's do it. Give it a 10. It has a round by 1 error, right? At the end of the for loop, we do a plus year. This is the round by 1 error. If you guys can understand this code, you will be understand the for loop, and you know why it's 9. This is wrong, right? And anyway, so any questions on it? Function call, right? Why we define these numbers to be a variable? You could change, right? Because you could use your function call in different ways. Each time you apply a different year, the number will be different, right? All right. So about return values. So the return values, we said it has to be a fixed type, right? And as you can see, you can do something like this one. If some condition, you return something. Otherwise, you return another thing, right? That's totally valid. But what you cannot do is do this. If p greater than 0, return, but not the other case. So if you are supplying a p that's negative, what do you return? Nothing, right? Nothing in C++ means void. You are returning a void. Void and double is different, right? So you cannot do that. Let me try it in here. We say if p is greater than or equal to 0, we could return. All right, let me make it simple so that you guys will get confused. All right, do this. It's valid. All right. you can write it in this way. Instead of assigning the result to some variable, then return the variable, you could immediately return this expression, right? Whatever you want to compute, just return the result. It's exactly the same as assigning to some variable, then return the variable. They will be the same. But as you can see, the compiler will complain in here because you forgot the negative part. You should say else return some number, right? Now it can work. So you need to consider all the scenarios. Every scenario need a return. Or you can just remove this line, right? It can also work. If it's greater than 0, return some number. And if p is greater than 0, it sees a return, it will immediately return. It will not run line 6. And if it's less than 0, it will go to the line 6. So in all the scenarios, there will be a return, making sure that, right, if your return type is not void, always have a return in all scenarios, not just one or a few of them. We introduce a function, right? Now we introduce another name called predicate. Predicate. It's basically a function returning a Boolean. If a function returns a Boolean, we sometimes call it a predicate. And we will use it in next half of the semester when we talk about the template and many other things that's very complex we need to write. We will use a predicate as a template in some template of the classes. So you guys will learn that. But the only difference is return type is Boolean. Then we call it a predicate, right? Sometimes you don't have to call it in this way. You don't have to understand what's inside here, right? It basically says if x and y are approximately equal. So for instance, if x is 0, if y's absolute value is less than some epsilon, then we say x and y are equal, right? And we, as you can see, we define a constant double here. Still remember what is constant, right? And for a constant, we making sure the variable are all capitalized, so we can distinguish a normal variable versus a constant variable. And as you can see, we have a if return, and if they all of them doesn't match, then we will go back to the last return, right? So for all the cases, we have a return. And here is how we can use a function that returns a Boolean value if function call, right? If the function call, the return value is true, we do some work. If the return value is false, we do some work. So that's the basic difference, the return type. If the return type is Boolean, it's called a predicate. If the return type is, let me see. Let me go back to where is the void part, right? Let me jump to here first. If the return type is void, we call it a procedure, right? So if the return type is a Boolean, it's called a predicate. If it's a void, we call it a procedure, but you don't have to know the exact name, but it's the typical way we call it. So we said when we're missing the return, it means we are returning a void, right? That's also when we said in here, there are indeed two return types, right? First one is return a double, second one is return a void. That's why this one is error. We can only return type double. We cannot return type void. So in this one, there will be some errors. And for void, it's there will be no return, but indeed it's doing some work, right? For instance, in here, it's returning, outputting some values. And in the future, when we learn about, maybe in this class, maybe next class, when we learn about references, even if the return type is nothing, we can still modify the values inside our functions. So that's something you will learn. And the void, the return type as void are very frequently used. So remember the name void means no return, or a no return. All right, so when we call a function, right, we give it some numbers like this one, call a future value function. The first one go to initial, second one go to P, last one go to the year. And we said we will first evaluate the result. Total divided by 2, first get the number, then copy it. Rate, evaluate, copy it. Year 2 minus year 1, evaluate, and then copy it. So the process is like this, right? In our main function, when we call the future value, we will first compute the argument total divided by 2. Evaluate it, copy it to the first argument, first parameter, the rate, copy it to the second, year 2 minus year 1, first compute the result, then copy it to n. So that's the process of the copying. All right. So this is the function call. So any questions on it? Nope. All right. So we will have the mismatch, right? Either mismatch in the argument, the parameters, or mismatch in the return type. For instance, if the square root, right, we are expecting a number, a double, right? But you are giving me a string, then there will be a mismatch. There will be some errors. And in here, because our return type of square root is a double, and we assign it to some string, we also give it a mismatch, right? So all of them will be catched by the compilers. So you don't have to remember that, but this one is catched by the compiler. So you will fix that when you are submitting your code. All right, so with that, we say functions are very important because it's the way we can split our problem into very small pieces. For every piece, whenever you implement, you can forget about it, right? Remember this one? We said whenever we implement the future value function, we don't need to take care of the details about it. The only thing we need to know is what is the input, what is the output, right? Treat it as a black box. Directly use it. Treat this one as a black box. The only thing you need to know is what's the input, what's the output. In this way, you are trying to make sure the problem are abstracted, right? So in the real life problems, the problem is so complex. You have to think it modularized way. You need to split your problem one by one and think about the interface only, right? These are something we call interface, only the input output. Otherwise, you will get lost when the problem becomes too complex. All right, that's the modularization. And we will go back to here when we talk about recursions. Because in recursions, the thinking process is so complex, you have to think it modularized way. But for the problems we encounter now, they can be just think about them step by step, right? You don't have to modularize it, but in the future, you will know that. So we will introduce something called a stepwise refinement. So whenever you think about a problem, think about it step by step. And for every step, you can enclose them as a function. For instance, a very simple problem, right? For example, you want to get a coffee, right? You can ask someone else to do it or make coffee. Then you can write a function called make coffee, right? Inside of make coffee, and what you can learn is, okay, we can make instant coffee or you can brew coffee. Then you can create another function called brew coffee. Then in your make coffee function, you can call brew coffee function. In your main function, you can call make coffee function, right? It's a one function call enclosed by another function call enclosed by another function call. Then in this way, you are making sure your problems are split into smaller ones. Every smaller problems are easy to solve. These are called stepwise refinement. And then you can, indeed, you need to practice that in your assignment, homework, lab exercise, and many of them. Another interesting thing I want to introduce is called unit testing. Unit testing is very important for writing very large programs. Right? You will write different functions, and for every function, you test if they meet your expectation, right? For instance, if I have a function, right, called int name, convert integer to English, then you can put a functions. We have already defined a function called assert. That's in the library, and then you say assert integer of name 19 should be 19. So before you write your int name function, you can write a bunch of assertions to making sure your program is correct. Your int name is correct. And whenever you modify a little bit in your int name, you have to also maintain all these tests passed. And we will show it if the time permits in a few weeks. We will show how we can use these ones. But for now, you can use the print function to test if the input-output matches. Many of the good framework, like the Google test and the Boost test, etc., they have many of the implicitly they write in their framework such that whenever you write a function, you write a unit test, and they will automatically test if your program you write matches your test case you have write. These are called test cases. So we will, if time permits, we will show that, but not now. All right, so as an access, go back and debug this code. There should be no bug in here. What I want you to know is you need to use the breakpoints to trace how this program runs. All right, in here, inside the main, it calls G, right? It will run to here. Whenever you run in here, it will jump to G. And when it goes to G, go to this line, it will jump to F. And it will go to here, and how it returns back, and so on. Go back and play with it. Create some breakpoints to see how the function call jumps your control flow. All right, so these are something about functions. And what's more important is today's topic is arrays. We have, so until now, we have talked about a single element, a single integer, single double, single float, single character. What we want is a sequence of numbers, sequence of array, a sequence of, for example, characters and so on. So arrays are used as a way to store a sequence of things. It's indeed, you can think of it as a first data structure we learned, right? And they occupies the continuous memory location. Remember this one, continuous memory location. So if you have 10 integers in memory, they occupies 10, one after another, right? And in the future, when you learn another data structures like the linked list or many other things to store, also store a bunch of numbers or a bunch of things, they are occupied different parts of locations and they connect each other. But in arrays or vectors, you don't need them to be connected because they are continuous. So accessing them will be very easy. So we have two ways to define arrays of vectors. One is called array, one is called a vector. So array is the old C way to define a bunch of things. It's very fast, it's old, but it's dangerous. It's dangerous to use. But you will still see many people use arrays because in the old ways when we teach in many years ago, all of us use arrays. So that's why nowadays even very experienced programmers still prefers array sometimes. But vectors are the new ways. It's defined in the standard template library. It's called STL. In STL, there are many data structures. Vector is one of them. Vectors and arrays are almost exactly the same. So underlying vectors, they define array. So vectors is just a something wrapped around arrays. So indeed, inside it, it's just arrays, but it's adding many applications, many functions you can use. You will see the difference. And it's new, and it's slower than array. But the speed difference is very minimal, so you can ignore that. So in our class, I would suggest you to use vectors instead of arrays because arrays are sometimes dangerous, but vectors are very stable and it will catch many of the errors you might happen. So in very large companies, when they are doing the framework implementation, they would prefer to use vectors because it's more stable. So here is something we will have. For example, you have a bunch of salaries, right? Instead of storing them in 10 variables, double salary 0, double salary 1, all of them are independent variables. We could define in the old C way, this is the array. This is the C way define array. This is the new way to define a vector. They are exactly the same. Basically, in the memory, it gives you 10 locations of double, right? Each space is enough for store a double, and they are continuous in your memory. And there are 10 items. So that's the beauty of using just one variable name to define 10 doubles, right? So that's the way we define arrays of vectors. So for a vector, it basically says a vector of a type. It can be a type name, right? When you combine vector with a type, it becomes a new type. Vector of a type becomes a new type. All right, let's put it in here. In order to use type, you need to include the library called vector. And because vector are defined in standard library, it's called std vector. We can define. So vector of a int is a new type, right? This is a type. This is a variable called a salary. So salary is a variable. Its type is a std vector int. It's a vector of int. And we said vectors can include any type, right? Because vector of int is a type. So it could be vector of vector int, right? Because vector of int is a type. It could be a vector of vector int. It could be vector of vector of vector int, right? You can continue on and on because everything becomes a new type. And also in a function, right? In a function like the, for example, if we compute the average of a function like the S, right? It can also work. It's a type, right? It's a type. It's a parameter, right? You know how to write a function like this, right? Then you know how to write a function like this. It's just a type. Vector of a type becomes a new type. Every place you can put a type, you can put a vector of some type, right? So any questions? Any place you can put a type, you could put a vector of type. And when you go back to here, it says vector of some type name, right? Type name could be also another vector. So you can go on and on and on. And also it could be some object. So we haven't defined this one, but these are, for example, you can define a class called employee. Then it could be a vector of employees. Then staff will store 20 employees, and also it becomes a new type called a vector of employee, right? And you can define any type in this way. So how can we initialize a vector? We can initialize in this way, give it numbers, right? Just give it 1, 2, 3, 4. Then it automatically knows the vector, the size is 4. And the elements, the first one is 1, second one is 2, third one is 3, last one is 4. And also we can do is, we can specify the size 4. The next one is optional. If we put it, it means 4 tens, right? So, and the last one is copying from one vector to another. Let me show it here. Erase this part. Right, this is something we can define. Nothing. Then it will be, the first line is the empty vector, or we can specify 1, 2, 3, 4. Right, this is valid. We are putting 4 elements into the salary. Oh, I redefined it. Salary 2. Or what we can do is, we can define the size as 5. It's valid. We can also define 5 tens. It's valid. We can also define salary 5. using copying everything in salary 4 to salary 5. All right, all of them are valid. First one, empty factor, contains nothing. Second one contains 4 elements, 1, 2, 3, 4. The third one, size is 5, all zeros. Next one, size 5, all tens. Next one, copying salary 4 to salary 5, right? All of them are valid. So we can use the, it's called a bracket to access a specific element, right? For example, we want the 4, salary 4. Salary 4 means the 5th element, the number 5 element, 5th element. Everything in machine, they kind of start from 0. So if it's salary, the size is 10, it's actually salary 0, salary 1, salary 2 until salary 9. There will be no salary 10. All right, if the size is 10, there will be no salary 10. All right, salary 10 is outside of your salary. It's another guy's memory location. It will be out of your boundary. So you can do something like this. Salary 4, assign it to some number. Or you could output salary 4 like this, right? This one is modifying the value. This one is read the value from salaries. And you can think of salary 4 as an independent variable. Right? You can think of that way. It will be easier to help you to understand. So for instance, in here, right, what we can do is, how about I change salary 5, the first element to be 0, right? You can do that. And also you could see out salary 5, 0. The first element in salary 5, right? You could see out of that. Then you would output 0, right? Here you modify the data because without it, it should output 10. It should output 10 because salary 5 is a copy of salary 4. Salary 4 is 5/10. Then if you didn't modify the first element, when you output it, the output should be 10, right? If you modify it, you modify the first element, then you output the first element, the element is 0. And we said it can be in the function call, right? Let's practice writing a function. We could return a void just to print a factor. We can write this kind of functions. If you give me a vector of integer, I'm trying to print something. And for now, let's just output the first element. In here, we could say print, right? I don't need this amount of things. Let's make them simple. Salary, salary 2, salary 2, salary 2. All right. Make it simple. So in here, we call the print function. Right? Print function is a Boolean, is a return a void. So we have no return values. We don't need to assign it to some number, right? You cannot do that. There's no return for the print function. It's just a cout. It's just a cout. And when you call print, it will copy everything in salary to the variable name you defined, cell, right? And in here, when you copy it, you just print the first element of your salary. And let's do print salary 2, print salary 1, right? Let's do that. So you output a 10, that's the first element of salary. Output a 0, that's the first element of salary 2, right? And we said, because the salary has only 5 elements, we cannot output salary 5, right? Because we only have salary 0 to 4. We don't have 5. Let's run it. Build successful means compile successfully. And my compiler has a assertion called factor out of my bounds. It is good, but I'm not sure if your compiler will do that. Let me try it in my server. Different compilers may be doing differently. All right, let me compile it. No errors, right? When I run it, yeah, it can still output something. So different compilers will have different behaviors if it's outside your boundary. As you can see, Sari 5 is outside of my boundary, right? I believe in your compilers, it also don't have any errors because that's the standard in C++. They don't care if you access outside of your memory, but that will be very dangerous. So, but this compiler, I believe it's clean, it is good, but for your compiler, it will not complain that. Anyway, that's something in the future. So any questions on it, on this part? No? Now let's talk about something. Oh yeah, by the way, this is the thing I'm talking about. If the stuff has 10 elements, you cannot access stuff 10. It will be outside of your boundary. It happens in many beginners, right? We do not have stuff 10, but most likely your compiler will not complain. You can run it like my server do, right? You can still run it. It will give you some output. You will never get the errors. But some of the machines, like the compiler in my machine, it has errors. But anyway, it's a so next we are talking about the for loops. So most likely the vectors are combined with for loops for a vector that's very, very long. And we are trying to manipulate every element in your vector. We will use a for loop combined with some functions. So let's look at here, right? Instead of outputting only one element, I want to output all the elements of my vector. So what we can do is for int I equal to 0, I less than Sari.size plus I. We could see out Sari of I. Let me make it easy to see. All right, this is the way we print a vector. Right? It's a for loop from 0 less than the size. If the size is 5, it is I less than 5. Right? If the size is 5, it's I less than 5. So it should be 0, 1, 2, 3, 4. Right? 0, 1, 2, 3, 4. I is 0, 1, 2, 3, 4. We see out the Sari of I, then put a tab key. Right? So let's print it. So the first salary contains 5 tens. When we print this salary, it print 5 tens, right? Separated by a tab key. And the second salary, because we modify the first element is changed to 0. All the others are exactly the same. Right? So that's the way we iterate through all the elements in a vector. And this is the typical way we print a vector, right? First, each element separated by a tab key, and at the end, put a new line. So this is the typical way we print it. Any questions on it? As we can see, instead of putting a magic number 5, right? We put a v.sari.size. It can still work because we know the exact size. But if we put a sari.size, it is correct for any sari, right? If I change it to 2 tens, then this size will change, depends on the input, right? And then when you print it, salary 1 output 5 elements, salary 2 output 2 elements, right? Because we use salary.size, it's not a fixed number. It will change, depends on your input. If your input are different size, it will output different numbers. All right, so we use size here instead of a magic number, right? This is a good way. And this seems a weird notation, right? The first part is a variable. It's a variable. It's a vector variable, dot. Then a function call called size, parenthesis. It's indeed, a vector is a class. It's a class defined in std library. It has many functions defined inside that class. We will learn that in maybe a few lectures later. But at least for now, just remember how we use it, right? The vector variable name dot a function call called size. Then we can get the size. And here is how we can modify a vector. Instead of doing it in this way, right? This is a weird way, just defining a fixed number of some integers or something that will be weird. What we can do is we can use pushback to modify our vectors. Let me do that. Erase this one. Let's start with a empty vector. Then first, salary.pushback 10. Wait, pushback at 10. Let's print it. Pushback at 20. Print it. Pushback at 30. Print it. Let's look at how it works. First is empty. If we push back 10, it's 10. When we push back 20, it's 10, 20. If we push back 30, it's 10, 20, 30, right? Whenever we say push back, we push to the end of your array. So when we push back 1, 10 is the salary 0. 20 is salary 1. 30 is salary 2, right? So here is what we call pushback, push to the end of your array. It's not the beginning, it's the end of your, and also we have another one. We'll talk that later, but let me show you here, called a pop back. Push, pop, right? So when we run it, 10, 10, 20, 10, 20, 30. Then when we pop back, it becomes 10, 20, right? So each time, push it to the end, push it to the end, push it to the end, a pop, pop, pop. That's the only operation we have because arrays are stored sequentially. We cannot pop any number in the middle. We cannot do that. The only thing we can do is pop the element in the back, right? Anything in the back, we pop it or push it. That will be no problem. And as you can see, whenever I push one, the size changed, right? For instance, if I put it in here, std cout, the size of vector is if I want to print the size first, right? Let me see that. So at the beginning, size is 1, output 10. Then when we push back, size becomes 2, output 2 element. Then we push back again, size becomes 3 element. When we pop, the size is 2 elements. All right, so that's the typical way we do that. And if you guys can still remember, we have the seeing functions to get the salaries. So let me get a salary s, right? And we said while std seeing s, we do salary dot pushback s. I'm not sure if you guys can still remember this code. Asking the user to input as many salaries as they want, right? Then we end with a Control D. Let's see what it will happen. I input 10, 20, 30, 40, 50, 60, then end it, right? It will output the size of the vector is 6, and this is my input, right? So push back, it can be used in a loop to continuously getting the user's input. If you guys can still remember, when this while loop will end, right, when my Cin fails. Any questions on it? No? All right, what we can do is, for example, what if I want to compute the average of the series? Average. Let me call it a function like this. I haven't defined this function yet, but I want to see out my average. Right? Then I can define this average function. What I can do is, okay, I can write a function called average. What my input is a vector, right? And we can define the sum to be 0. And for all the elements, what I do is sum plus equal salary of I, right? At the end, I return sum divided by salary dot size. This is a function that takes a vector of integers and compute the average. Right? We have a variable called sum to sum them, and we iterate through all the elements. And for every element, we add to the sum. And at the end, we return the sum divided by the size. Right? This is something we can do. For instance, if I input 10, 20, 30, and the size is 3, the element is 10, 20, 30, the average is 20, right? This is my output, average is 20. So this is the way we can use vectors. As you can see, vectors are frequently combined with a for loop, right? And we can put it into the parameters, and we will see later how this one can be changed. And there are 2 ways actually to push back. First one is you didn't specify the size. You just push back. This is a typical way I do. Or if you know the size, right, then you can assign the size. Assign to each element instead of pushback. If you do pushback, the size will be changed. Is it 10 becomes 11, becomes 20, becomes more. So if it's empty, you can do start from 0 to pushback. If you know the size, you can define the size, then assigning to them one by one. So I would prefer the first one. It's slower than the second one. So the bottom part is faster because you are not changing the size of vectors every time. The first one, you are changing the size of vector every time. It's indeed underlying the implementations. What they are doing is they are doubling the array size every time in their implementation. But anyway, that's another story. But you can use any of them, right? Remember, the first one use pushback, the second one use assign. They'll be slightly different. And a pop back, we have already said that. All right, so as an exercise, you can read in all the salaries. Right? How can we read in? Read in, either use my way in here, which is this simple way, right? Read in the salaries, push back to an array, or you can do is using a sentinel, right? Ask the user to enter salary 0 to quit. If it's not 0, you push back into your vector, right? If it's 0, you stop. And that's the way you can get it from the input. And how to compute the largest salary? What do we have learned? This part is compute the largest one, right? What do we have? You guys should be familiar with that. If the current salary is greater than the previous highest, update the highest, right? That way we can get the highest one. So first we assign highest to be the first element. Then for every element, for every I, if the current salary is greater than the previous highest, then we update the highest. This is how we can compute the highest salary in a sequence of numbers, right? It is also true in a vector. And the last part is the outputting. I want to output exactly the same as the previous slide. As you can see, if the salary I is equal to highest, we will put an arrow and highest to it. What you will get output is like this. You will have an arrow and highest to specify, okay, this guy is the highest. All right, do this as an exercise. It should be quite easy. So this one, I will show you this one. I want to write a loop that fill in a vector with 10 random numbers. So I haven't talked about how to generate random numbers. Indeed, I will not talk about it. You should search online or ask GPT, okay, how can we generate the random numbers in C++? So I give a hint here. It's a srand and a ren. I will show you how this one are used. So first you need to include the std library. There are two functions, right? Instead of getting this one, we will generate 10 numbers. 10 numbers. Each number is a random number. Wait a minute. Unexpected print. Why print doesn't? Maybe I cannot use print. Vector print. How about that? No. Let me see what's happening here. Oh, I forgot the brace. Yeah. All right. So I push back 10 random numbers. Then I print them doing the average, right? Let me run it. Some very large numbers, right? If you look at the explanation about rand, it's actually returning a random integers. So how can we get a number, a random number between 1 and 100? Assuming I have a random number that's any integer, how can I get a random number between 1 and 100? More 100 plus 1, right? And in this way, I will get a number between 1 and 100. Random is just a random number that's generated by the machine. All right, we will get 8, 5, 74 something, right? And we can compute the average. Let's run it again. Remember the number 850. We run it again, it's still 850, right? It doesn't seem a random number, right? It's kind of fixed the sequence of number. That's exactly what random number in programming means. They are called pseudo-random. It's not exactly random. It's just applying some function. For example, applying function to 8, you will generate 50. Apply the function to 50, you will get a 74. So that's why in a machine, it will be very easy to do debugging, right? If you are having a random here and getting some errors, you want to repeat the process. You just need to run it again. You will get exactly the same number. You will be able to reproduce the errors. How can you get the real random? Called srand. You can fix another seed. If the seed is fixed, the output is fixed. For example, if the output is 0, it's 31, 92. Run it again. 71, 92, right? If you fix the seed, you are actually fixing the random number generator. If you change it to another one, now it's 71, 31, and 92. Now it becomes 8 and 50, right? So you will have different numbers by changing the srand. Sometimes you can use your current time. I haven't talked about it, but you could use current time What kind of time you need to give a input? Anyway, you don't have to know it, but it's basically using your current time as a seed for your SRAM, and then generate some random numbers. It's quite random because each time you run it, your timestamp is different, and then your random sequence will be different. All right, so that's this exercise. You can ask the GPT to generate this one. It will be quite easy because GPT can help you with that. So the last topic I want to talk about, which is also very, very important, is when we use the factors as a parameters, we said we are copying the factors. Let me go here. Right. When we are coming into the print, we are copying the factors. Let me show you what we mean. What if at the end, I change the salary, the first guy becomes 0? What we will do is, let me delete this part. Print salary first. Then next we do print salary. We do twice. All right, let me put a breakpoint in here. First one, when we go here, these are salaries, too many numbers. Let me just use 2, rerun it. When we go here, the salaries size is 2. First item is 8, second one is 50, all right? Now let's step into our function call. We said we are copying salary to the parameters. As you can see, yeah, it is successfully copying it. The first item is 8, second item is 50, right? No problem. And then we output, then output 2, and output 8 and 50, right? Then we see out a new line. Then we are trying to modifying the salary cell inside the function call. So as you can see, inside this function call, this SAL, the first element becomes 0. The first element becomes 0. When you jump out and execute this line, the first element of salary is still 8. So what we are trying to do is, we know that this is our salary, SALARIES, all right? It has 2 elements. First one, I don't remember, some number and some number. When we call the function, it will copy this guy to cell, right? It points to another part of location. This guy copy here, this guy copy here. And at the end of this function, it will be modified to 0. But we are not modifying this element, right? Because we are copying all the values to the parameters. What we are trying to introduce is another thing called reference. If I put a and sign here, now the story will be different. When we run it and we jump into it, it's exactly the same, still 8 and 50. But when we run it, run, output 50. And when we go here, the local variable inside your print function, the first element is 0. When I jump out, run it, this guy, the first element also becomes 0. All right, so we call it a reference, or passing by reference. So if you execute it, it will first output 8 and 50. Next, we will output 0 and 50. The reason is in our salary, right? SALARIES. In our salary, we pointed this. When we call this function called cell, it's not creating a new space. It's just a new name it's still pointing to the same location. It's just giving salary a new name called cell. Why do we do that? Because copying every element to another memory location is time consuming. And for this one, it's just 2 elements, no problem. What if your vectors contains millions of elements, right? If you are doing copying, it may take seconds or minutes to do the work. So your compiler, or when you are implementing your program, what you are trying to do is making sure vectors are not copied so that your program will run faster. And they are just the same name pointing to the same location, a different name pointing to the same location, right? So let me delete this one. Let's watch it again. Let's delete this part. I don't need the size. The only thing I need is the change it in here, right? First time run it. It contains the and sign. It's a passing by reference. It's just another name. Salary is just another name for a cell is another name for salaries. If I delete this guy and run it, it's the same, right? Salaries doesn't change. It's called passing by values. It's copying the cell. Is copying everything inside salaries. It's creating a new space. So that's we called a reference. And a reference can be used in this way, can also be used in another way, like this. It can also work. It's just giving it a new name. Maybe it's hard to understand. Let me create another one. Let me use this. All right. So in here, assuming I have the first variable called I, right? We could create another guy called j equals to I, equal to I. And let me change I to 1. Then let me see out j. So that is something you can understand. Wait a minute. I keep typing the wrong key. So we first define a variable I, define a new reference to I, and then we change the I, then we output j, right? So what you can do, compile it, then you can run it. As you can see now, j is 1. J is 1. Initially, j is 0, right? You're assigning j to I to j, then you modify I, you output j. So what if you delete this guy? You delete this reference. It's really assignment. It's really copying, right? You're not doing a reference. And if you run it, you will output a 0, right? That's the reference. This concept is very important. It's when we are doing this way, j is just another name for I. They are pointing to the same location in your memory. So whenever you modify I, you're also modifying j. It's called a reference. And in the future, when we learn pointers, it also mean similar things, but the pointers are more powerful. But references are easy to understand. Think of it as another name, right? Pointing to the same location as salaries. So when you are trying to do it, copy it into salary, it will do the it will also point to the same location, and whenever you change it, it also changing the salary. So as we said, void functions are very common with the help of pointers, right? Even it's void, you are still modifying something. For instance, if I trying to return the average, right? Instead of returning it, what we can do is define it as void, but pass by reference your average. In here, you say average equals to this guy, done, right? You have a factor, you have another one called average. Let's run it. How can we run it? We need to define average here. Then we call this function and put your average in here. So now average will be changed inside your AVE function. And you can output it. Right, you can output it in this way. Wait, your average is 25? It's weird. Oh yeah, because in your print, you modify the salary, right? Yeah, that's good. All right, so as you can see in the print, we pass by reference of the salary. So it modifies the first element in salary. It becomes 0 and 50, right? Then when you call AVE function, it will pass by value, copy everything in salary to cell, and average, and also the AVE is just a different name pointing to the same place. So inside this function, when you change AVE, you also change the average outside your function, right? This one, they will be changed. It's too far away. Let me put them together. All right, I'm not sure if you guys can see it. Right, so average, go to AVE, pass by reference, AVE and average pointing to the same location. Salary and cell are different. These two are different because we pass by values. I could also put a reference here. It's passing by reference, then salary and cell pointing to the same location. Just different names. Average and AVE pointing to the same location, just different names, right? This is the reference. We call it a reference. And we said we could use void functions, right? Almost every function we can rewrite it as a void function. Every return variable, you can just put it here. So that's also the benefit of reference, right? So for instance, we said, in our typical way, we cannot return two things. How can we return two things? We can return two things in this way, right? And we could have error message. Then we can put it here, right? Indeed, we are returning two things. We are returning the average. We could also return the error message. For instance, if salary of cell the size is 0, then what we can do is error message becomes empty. Then we can return nothing, just a return, right? So in this way, we are not only outputting the error, but also outputting the average. Right? With the void, you can with the reference, you can put as many return values in here as possible. Right? You can write a long thing if you want to return many things. Any questions on it? No questions? It should be confusing to beginners, right? When the first time you see it, it's a very important concept. Yeah.
把一个变量让它 reference 另一个变量，那我还不能让它再进行一个 reference
可以。
其他的变量。
可以。Yeah, you can also do that. If you have a reference to this guy, we could also have a reference K to J, right? Let's output K. Let's output K. It can work. compare it, run it, right? J, okay. What do you mean is if I have another int w, right? Indeed, it can only be referenced when the first time you define it. So the first time you define int j, you cannot say that. You have to specify which number it's pointing to. Yeah. So that's basically the bad part. You cannot modify that. Anyway, so any questions on this kind of problems? The usage of reference in function calls is very important, right? Passing by reference, save some space, So you are not copying all the elements for vectors. Also use reference point and reference as a return type, right? So that's a very important concept. Any more questions? Yes.